Okay, so this should be recording. So I'm just going to post examples of a few different 3D problems, and I'm not really going to edit them because I only have about 40 minutes to record this. So yeah, here we go. All right, so this problem is asking us, let's see, we have engine hoist, and we're trying to find the point in the xy plane where the resultant of all of these forces intersects. So we have 1, 2, 3, 4 forces, and they're all going in the positive z direction. So what we want to do is we want to first find the equivalent force couple if all of those forces were acting at the origin. All right. So we've got 4 forces going on, so the sum of the moments around the origin is going to be equal to R from the origin to A crossed with the force at A plus R from the origin to B crossed with the force at B plus R from the origin to C crossed with the force at C, and you can probably guess the last one, crossed with the force at D. So we have to find all of these things. So we have, let's see, so for ROA, I'll write it down here, ROA, we're going to have, let's see, we're going to move negative 16 in the y direction, and then positive 24 in the x direction. So I'll just draw it here. That's the negative 16, and this is the positive 24. So that'll be 24 inches, so x hat, and then minus 16 y hat. All right, for OB, we're starting, can I erase this? We'll do it in a different color too. So OB, we start at the origin, and we're going to go again minus 16 in the y direction, and then minus 20 in the x direction. So minus, let me do that, black in. So this is minus 20 in the x direction, and then minus 16 in the y direction. Oh, and I'm using these instead of IJK, just because I forgot. All right, so now we want R from the origin to C, and that'll be plus 19 in the y direction and plus 76, or minus 19 in the x direction, so we'll do that, minus 19 in the x direction. So that is going from starting at the origin, we're going to go right here, minus 19 in the x direction, and then we're going to go plus 76 in the y direction. All right, and then finally starting at the origin again, we'll erase these. So we're starting at the origin, and we're going to go to D, so that is plus 20 in the x direction, and then plus 80 in the y direction. So ROD equals 20 in the x, and what did I just say? 80 in the y. I'm doing this totally off the cuff, sorry. Right, and then all of these forces are going in the positive z direction, so FA is equal to 60 pounds times z hat. FB is equal to 30 pounds times z hat. I'll put pounds here, pounds. FC is going to be equal to 210 in the z hat, and FD is 270 in the z hat direction. Okay, so now we found all of our R's and all of our forces, so to get this moment, we got to sum them up. Oh, and I'll write this as a vector too. So the sum, well, here, I'll write them one by one actually is what I'll do. So ROA crossed with FA And I'll do this the determinant way because the feedback I've gotten is that most people are more comfortable with that one. So x, y, z. 24 minus 16, 0, and then 0, 0, 60. Okay, so then the x component is going to be minus 16 times 60. I have MATLAB up somewhere. I'll find out later if you can actually see this. Alright, so 15 times 60, 960. So that's minus 960 in the x direction, and then the y is going to be 24 times 60, so 1440, and that one will be negative because you always add the negative sign to the y components, so minus 1440 y hat. Okay, so we'll do the same thing for all the others. And if you want to skip ahead at this point, because it's just the math, please do. That's why a video is great, I guess. Or you can just hear my dulcet tones. Dulcet? I don't know. 0, 0, 30. Okay, so we've got in the x, minus 20 times 30 is minus 600. I can do that math. And then y, oh shit, sorry. Apparently I cannot do that math. X, it'll be minus 16 times 30, which should be minus 480, right? Yeah. We X that, and then the minus 20, that'll end up picking up a positive sign because of that thingy. So minus 20 times 30, and there's a 600. And again, that's positive because it's the y hat component. All right. ROC cross FC. Writing. Minus 19 plus 76, 0, 0, 0, 210. All right, so the x component will be 76 times 210. 15,960. Minus 15,960, or plus in the x direction, and then minus 19 times 210. $3,990. So 3,990. Sorry for my terrible handwriting in the y hat. And then those would be negative, but we're switching it to positive because why? Why? That's a good question. Why? ROD cross FD. One more. 20, 80, 0, 0, 0, 270. 20 times 270 should be 540, or 5,400 rather, right? 2 times 27 is 54, add 2 zeros, yes. And that'll be in the negative y, so 5,400, and 80 times 270 is that multiplied by 4, so 21, that'll be 20,000 plus 1,600, right? Yeah. Hopefully it's that. So that'll be the x, and that'll be the y. Okay. Finally, thank God. If you're rejoining us, welcome back. Thank you for flying with us today. Alright, so the sum of the moments is summing up all these guys. I'm gonna move MATLAB to the other. You probably won't be able to see my magic MATLAB now, or maybe I can make it windowed. Imagine if I had done that way earlier. That would have been so interesting, huh? Alright. Okay. Minus 960, minus 480, plus 15, 960, plus 21,600. So, you are 3, 6, 1, 20 in the X direction. No, MATLAB, where'd you go? Don't you walk out on me, MATLAB. Don't you do it. Oh god, my own handwriting fights against me. Hopefully that's a 90. Minus 5,400, not 1,000, 100. Okay, minus 1950 y hat. Alright, finally. God, okay. I'm editorializing a lot more than I normally would. Alright, so what we have now, we have x, y, z. And this is our origin. And we have a, oh god, I gotta add the forces. Okay, one more thing. R is the sum of the forces. Alright, so for the x component, or wait, oh, we just only have the z component, that's all it is, that's right. That's right, that's right. So 60 plus 30, I'll do 30 plus 270 is 300, and then 210 plus 60 is 27. I should just do the calculator. 570. Thanks, calculator. You're welcome. Alright, thank God. So we have that guy, we have a force, 570 in the z direction, and then we have a couple, which is in the xy plane. Technically, I just drew that so horribly, I'm not. Alright, and what we want to do is we want to find, there's a line of action somewhere. It'll be in the z direction because we know all the forces are in the z direction. And so I'll extend my x and y so you can see that. So this is the line of action. It's got z stuff. And somewhere there will be, from the perspective of this point, why'd you delete that one note? Okay, from the perspective of this point, this will be equivalent to this tuple. So remember R often, when you're talking about coordinate systems, is x, y, z. And so the weird thing here is the R from R cross F is actually the opposite of this. We're measuring from this point to the origin, whereas this R is from the origin to this point. So I'm going to write this as minus R, where R is equal to x, y, z. So what that means is that the sum of the moments around this point is going to be equal to minus R cross R plus m naught. And because this is along the line of action, that's going to be equal to 0. And so what that gives us is that R cross R plus m naught is equal to 0, or no duh. R cross R positive is equal to m naught, which I think is just an equation in the book, but I always just rederive it whenever I need to think about it. So, one more time, we move to the right. Take it back now, y'all. Alright, so R cross R, we got, be consistent, Andrew, x, y, z, those are the hats. So these are the unit vectors, and these are variables. I'll just change them to ijk. That's why they use ijk anyway. And also because the dude named Hamilton wrote it when he was on a bridge one time. True story. Alright, so we have x, y, z, and we know in this case it's going to be in the xy plane, so we can just delete the z, make that a 0. And then our force is 0, 0, 5, 70. And we want this, that's R cross R, and so that should be equal to I should write it as a vector type. Gonna move over to the right a little more. 3, 6, 120 x hat minus 1950 y hat. I really hope I didn't make any algebra mistakes, because that would be embarrassing. Oh yeah, and I changed it. Thanks for bearing with me. These problems take forever to do. Yes, alright. So, we take the I determinant, so that the I, that'll be y 570 in the I direction. And then the j, we're going to have x 570, and that'll be a negative sign in the j direction. 36 120 I hat minus 1950 j hat. Okay, so if we equate the i's and the j's now, we have y times 570 equals 36 120, and minus x times 570 is equal to minus 1950. And we can now go to our trusty calculator, which I still don't know if you can see, because I don't know if it's recording my screen or the window. If not, I'm doing all this math in my head, because I'm just that good. Alright, y, no! 63.4 inches. X is equal to 1950 divided by 570, 3.42 inches. So that kind of makes sense if we look back at our figure, right? Because it's the line of action of all of these forces should be way over here in the y direction, and then just like a little bit over here in the x direction, somewhere like right here. Yeah, so that is problem 1, and I'm going to stop recording and pray that it worked well, and I'll come back with 2 and 3. Bye.